This video is going to demonstrate how to create this nut that will fit this bolt using Autodesk Inventor. Now there's a previous video that shows how to create the threads and actually this entire bolt. And now we're going to make the complementary nut using the same pitch. And actually it's going to be a very, very similar process. The only thing that's changing is the direction that we're cutting threads. And we're going to make our path a little bit longer than we did for the bolt in relation to the size of it. All right, so it's going to be a very similar process. Go ahead and follow along. It's going to be a little bit faster. Okay, I'm going to do my 3D sketch, create a helical curve. I like to start at the origin. Now, just like last time, I know pitch. I do not know revolution, so I'm going to use pitch and height. I'm going to get my information right off the drawings. My diameter is 14 millimeters. Actually, I'm going to do a slightly smaller diameter. This 11.84 millimeters represents the minor diameter of these threads. So I'm going to go ahead and use that. As far as height goes, I do not need to do 40 millimeters. My height here is actually 8 millimeters. However, I want to do probably 2 millimeters on either side. So my height is going to be 12 millimeters. And my pitch is still 2. It does not change. Just like the last one, I need to fully constrain this. So I'm going to use a bunch of origin geometry and coincident. Let's start with the center point on the center point of mine on the origin itself. Okay, I pick that up. I'm going to use an axis here. Maybe I'll try a slightly different axis this time. Instead of Y, I will do X. So collinear, the axis on X, and then I'm going to take this endpoint and put it on one of the planes. That one looks good. Now I'm fully constrained. Finish that. Now at this point, I probably want to go create my solid body of the nut. So I'm going to do a 2D sketch. I could start it right here, but I actually want to do an offset because I want to be in the middle of the spiral helix. So let's do an offset plane from the origin plane. And let's do 2 millimeters. So that's one complete rotation. And no, I lost it there. Where'd it go? Let's try that again. 2. Okay. As you can see here, I have a full rotation prior to, which is exactly what I want. I'm going to draw my hexagon shape now. 6-sided is what I want. And it went super small because I didn't give it a size. So let's give that now. So that's going to be 20. Now we'll go ahead and extrude that to 8. I actually forgot the hole in the middle, but that's very easy to change. Reopen my sketch, put my circle in there. Give it the same dimension, 11.84. Go back to the extrusion and select profiles again. I just want the outer profile. Okay, so here's where I'm at. I have my solid body, I have the path. Now I just need to create the profile at the end of the path. So I believe I put this endpoint on one of the origin planes, which I did, so that's where I want to sketch. Now, whereas the bolt, we had the tip of the triangle facing inside of the coil, we're actually going to face it outside, so we're just going to kind of reverse it. this is going to be 2 millimeters because that is my pitch. Like I lost my point here. Let's put that back on. So my point isn't here because that is not the origin, but what I can do is use project geometry to bring that point from the path into my sketch, and that is a critical step. If you do not do that, the sweep will not work. I know I have a dimension here of 60 degrees, and these also need to be equal, and that should be all the information I need. Let's go ahead and do our sweep at this point. The computer generally picks up the profile, and then you have to tell it your path that you're taking. And as you can see here, it does go all the way through, plus some extra rotation, which is exactly why we did that. All right, so there is the nut. Everything looks good on this side. Now with the bolt, what we did was we took off some of these sharp edges by going back and redoing the sketch for the profile. You don't necessarily have to do that with the nut. It is just due to its shape, it's not subject to the same stresses. One thing to keep in mind is depending on the tolerance of your 3D printer, which we're going to be 3D printing this in class, if you have too much interference, what you can do is open the tolerance up a little bit by making the hole here a little bit wider, or you can go to the 3D helix design and make that slightly larger to add in a little bit of tolerance for these 3D printers that, 20, 30 thousandths is pretty normal for, an off the shelf type of 3D printer. Something very, very expensive can be more accurate, but that's not what we have access to, especially when we're just starting out. So that's the nut. Best thing to do is to print it out and test fit it with your bolt. And if you need to make some changes, do it. Reprint it. That's the beauty of 3D printing. That's why we call it rapid prototyping. Change it, print it, test it, and then you'll have something that you know works. All right, so that's how to create a nut with a specific thread geometry on Autodesk Inventor.